Okay, so the next problem in the lead code we are solving is convert sorted array to the binary search tree. Okay, so as we know, this is how the binary search looks actually. And what is the condition here? Like basically the root node, right? Root node. If you take it as a root node, it will be always greater than the left. Correct? It should be always greater than the left, and it will be lesser than the right node. Correct? This is the rule for the binary search tree. Okay, it should be validating everything. Okay, and now before actually attempting the problem, right, we need to one thing here. So let's discuss that first. Okay, this is the binary search tree, and let's say that there is a relationship between the binary search tree and in order traversal. Okay, so let's see like what is the relation. So basically let's say that if we apply the binary search tree, right, like sorry, in order traversal on this one, right, how it would look like, I mean, in order meaning left will be first, and then root, and then we are going to traverse to the right node. Correct? So you should be aware of this traversal nodes, traversal mechanisms, like, I mean, methods, in order, pre-order, post order. Okay, so initially what does it mean? Left node, right? So we'll have to pick the left node here first, one, and then we'll have to pick the root node. Correct? This is the root node. And again, when we come here, there is a right tree, but before actually converting, reading this one, we'll have to go for this one. Correct? 1 3 4, and then the root, and I'm just applying the in order traversal for this one tree. Okay, so again we'll go to this and it will continue. Okay, so basically one thing if you observe here, like if you apply anytime, if you apply in order traversal on a binary search tree, it will always give you with a sorted array. Okay, that is like, I mean, kind of rule. Okay, like, I mean, that is the straightforward thing there. Okay, so you can try it out with the any binary search tree, so this will give you. Okay, so what just happened here is, so we have got a binary search tree, and we applied in order traversal. And what did we get? We got a sorted array. Okay, so now what they are expecting in the problem is, they have given us a sorted array. Okay, they are given us a sorted array, and they are expecting a binary search tree. Okay, so it is now what is happening here. So it's like a kind of backtracking, right? Like, I mean, we went in this way, but now they are expecting us to find it out this way. Okay, so they've given us a sorted array. We need to find out a BST. So now how to do it? Okay, let me clear this out first. Okay, so this is a given array. Okay, so this is a sorted. This is already sorted. We need to bring it back into a binary search tree. Okay, so now as we saw, right, like, I mean, we had a relationship that if there is a binary search tree, if there is a BST, and if we apply a in order traversal, we will be getting a sorted array. But now what we are going to do is, we are going to traverse it the to go in a reverse order. Okay, reverse engineering kind of. So we have a sorted array here. So we'll apply in order traversal to this, and we'll build a binary search tree. Okay. So how are we going to do it? In the in order traversal, what does it mean? In order traversal is nothing but equal to left, and then the root. Okay, and then the right. Okay, so this is the traversal mechanism. So basically this list should be splitted into the left, okay, and then the root, and then the right. So if you are able to split it down, right, so we will be able to build this tree. Okay, and also it has been given that we should be balancing it out. Okay, so simply what I can do is, I can if whatever the given number, right, I can just write it like this, right, minus 10 in a sorted order, right? So I can just simply write it like this every time. Correct? 5 and 9. So this is a binary search tree. Correct? So every time I will go like this one and go like this one. Correct? But yeah, like, we need to make sure that it's a balanced one actually. So I can write it number of ways, like, to make it as a binary search tree, but I need to ensure at the end it should be balanced one. Okay, so the thing is, as they say, it should be balanced. So that gives us a hint that we need to split it evenly, right? So what we are going to do here is, for a given sorted list, right, we are going to split it into half. Okay, so so now what will happen is, whenever we split, we know that the order is this one, right? Left, root, right. So we are going to consider this as a root. Okay, so whatever the given number was, right, it will be root, and whatever that comes to the left will be the left node. Okay, left, that will go to the left tree, and remaining will go to the right tree. Okay, and again in the right tree, we'll have to make the same analysis. Like, we are going to split it into half. We'll have to find out a mid index, and once we find a mid index, we will be like, making that as a root and building the tree evenly. Okay, so once we got a zero, right, basically we'll be placing zero here, and minus 10, and -3 will go here somewhere in the left tree, which will be going here, and here 5 and 9 will go here. Okay, and we'll apply the same analysis, like finding the length of it. Okay, and finding the length of it and finding the mid index of it, and based on whatever the root index that we get, right, we are going to place that here. Let's say that we get 5 here, so we'll be placing that, and remaining again we are going to split it. Okay, now let's see it in action. Let's see, check the code. So what we are going to do here is we are going to use basically the recursion way of solving it. Okay, so basically what we'll get a list. We are going to get the length of it so that we can identify the mid index, right? So that's why we are going to find the length of it, and we are going to find a mid index. And once we calculate an index, we need to make sure that it's a valid one, right? Or else it might get an index error. So we need to make sure that it is not negative or it is not going behind the given length. Okay, so this is one like kind of exit condition. This might, we might land into this like at the end of the trees, right? So we need to handle that. And once we get a mid index, right, we are going to create a node out of it. For example, here, right, my 10, we got a mid index, we will be creating a node for 0. Okay, so now it's the time, like now it is split it into, this is into the left tree and this is into the right tree. Okay, again we'll have to apply the same logic for this one. Again we'll going to find a mid index for this one, and we are going to make that as a root, and again we're going to split whatever that comes to the right will be right for the right tree, and whatever that comes to the left will be the left tree. Okay, so what is happening here? So once we find out that we have created a root node, and now we, it's the time to build for a left turn, get the no, final node, like whatever the node that we build, right, that one. Okay, so finally what's happening here, we are going to give the, for a child recursion calls, we are going to give the first part of the array for to build the left trees, and the next part of the array to build the right trees. So finally we are, whatever the, it should return as the node, this it will return this node -3 and 9, so we'll attach it and finally resulting it back. Okay, so like I mean, one thing to understand here is, like, we can come up with this solution. One thing we should be knowing before is the relationship between the binary search tree and in-order traversal. Meaning, if you apply the in-order traversal on a binary search tree, it will give us a sorted array. So if you apply the in-order traversal on the sorted array, you will get a binary search tree. This is the key term here. So if you are aware of it, we can come up with this logic, like saying, like, how did we encounter the, how did you identify the root node basically? Like as I said, it's the height should be balanced. We made it as a balanced one. I mean, we picked that one. Whatever that come to the left was the left, went to the left tree, and whatever that came to the right was went to the right tree. And using that, we started building the trees, and finally returning the root node for the problem. That's it. Thanks.